Welcome to Swayam Prabha, CAD. I am Dr. K.T.Mannan, Associate Professor, Mechanical Engineering, School of Engineering and Technology, Indira Gandhi National Open University, New Delhi. Today we are going to discuss the topic on computer aided manufacturing, CNC machines.
What is CNC machines? Computer numerical control is a method for automatic control of machine tools through use of software embedded in a microcomputer attached to the tool. So basically, it's a method for automatic control of machine tools through the embedded software. It is commonly used in manufacturing for machining of metals and plastic parts. Computer numerical control is an NC system that utilizes a dedicated stored program computer to perform some or all the basic numerical control functions. So the computer numerical control which consists of NC program and part programs which is stored in the computer, which is used to perform the all basic numerical control functions. The external appearance of the CNC is similar to the NC machine. The outside appearance, the external appearance of computer numerical control is similar to the numerical control machines. Part programs are initially entered into similar manner. Punch tap readers is device to input the part program and data into the system. Here the punch tap reader acts as a input device which is used to feed the input of the part program and data into the systems. CNC program is entered once and then stored into the computer memory. New systems options can be incorporated in CNC controller by reprogramming unit. The CNC system elements, which the figure shows the various CNC system elements, which consists of part program, program input device, machine control unit, drive system, machine tool, and feedback system. Computer numerical programming. Conventionally, an operator decides that adjusts the various machines parameters like feed, depth of cut, and etc. depending on the type of job and control the slide movements by hand by manually. But in a CNC machines and slide movements are controlled by motors by using computer program. The main components of CNC machines, which is coding, the part programming, input devices, machine control unit, drive system, machine tool, and feedback system. The programmed instructions are converted into output signals, which in turn control machine operations such as spindle feeds, tool selection, tool movement, and cutting fluid flow. These are the functions which is carried up by programmed instructions, which is converted into output signals. And it turns the control machine operations. The various type of machine operations, which includes spindle speeds, tool selection, tool movement, and cutting fluid flow. Integrating computer processor and computer numerical control is known as computer numerical control. Thus, integration of computer processor and computer numerical control is known as computer numerical control. It allows part machining programs to be edited and stored in computer memory. The part programming are for the various machining operation is to be edited and stored into the computer memory, as well as permitting to diagnostics and quality control functions during the actual machining. So during the machining time, it permits to the diagnostics as well as the quality control functions. The various functions of CNC machines, such as the machine tool control, in-process compensation, improved programming, improved operating feature, diagnostics. So the machine tool control, which have the two types of machine tool control, hybrid CNC and straight CNC. Hybrid CNC is a hardwired logic circuit for functions like feed rate generation, circular interpolations, etc. The mass production of circuits and less expensive in computer. By using the hybrid CNC, it's produced the mass production as well as the less expensive. But straight CNC concerns that computer to perform all numerical control functions. So that various functions such as machine tool control, it's control the machine tool activities. It's in-process compensation, it compensates the various functions and activities during the process. And the programming has been improved and operating feature has been improved, and it acts diagnostics of the functions. CNC part program, all machining begins with a part program, which is sequential instructions. So all machining programs, computer numerical control machining programs are sequential instructions or coded commands, which includes sequential instruction as well as coded commands, which is used to direct the specific machine functions. The part program may be manually generated or more commonly generated by computer aided part programming systems. Either it can be generated by manually are prepared by manually, or it can be generated by computer-aided part programming systems. The principle of computer numerical control. Computer numerical control machines are able to accurately and repeatedly control motion in various directions. So that computer numerical control, which can be accurately controlled and repeatedly control the various control motion in different directions, the various directions. Each of these directions of motion is called an axis. So each and every direction of motion is called that axis. Depending on the machine type, there are commonly 2 or 5 axes. Additionally, CNC axis may be either a linear axis in which movement is in a straight line or a rotary axis with the motion following a circular path. There are typical types of control systems are there. There are 2 types of control system in numerical control. The point-to-point control, so there is no contouring capability. Straight cut control, one axis motion at a time is controlled for machining. Contouring is a multiple axis control simultaneously. So all forms of CNC equipment have 2 or more direction of the motion called axis. This axis can be precisely and automatically positioned along the length of travels. Mainly the different types of control systems are point-to-point control system, straight cut control system, contouring, path control systems, or it's called continuous path control systems. So all forms of CNC equipment have 2 or more direction of the motion. The direction of motion is mentioned as the axis. These axes can be precisely and automatically positioned along the length of travels. The 3 motion control is the heart of computer numerical control. The most basic function of any computer numerical control machine is automatic, precise and consistent motion control. These are the 3 motion control, which is that it's automatic, precise and consistent motion of the control. These are the major basic functions of computer numerical control. Rather than applying completely mechanical devices to cause a motion as it's required as most conventional machine tools, CNC machines allow motion to control a revolutionary manner. Now come to the point-to-point systems. The point-to-point system, also called positioning systems. Each axis of the machine is driven separately by ball screw depending on the types of operation at different velocities. The same as which we discussed in the NC machines. So each axis of machine is driven separately by ball screw. The ball screw is used to driven each axis separately. It's based on the type of operation and different level of velocities. The machine moves initially at maximum velocity in order to reduce the non-productive time. So that to reduce the non-productive time, unproductive time, so that initially it moves in the velocity of the machines moves in very fast, so that the non-productive time can be reduced. Then it's declared as a tool reaches its numerically defined position, so that the tool reaches the numerically defined position set by the programmed instructions. There is an operation such as drilling, punching, positioning and cutting take place sequentially. This all operation takes place sequentially as prescribed in set of instructions. The time required in the operation is minimized for efficiency. The point-to-point systems are used mainly in drilling, punching and straight line milling operations. This figure shows the point-to-point drilling and boring operations. So this workpiece, this tool is moving from one point to another point, another point to another point, another point to another point. So it moves from one point to another different points. So it's called as point-to-point systems. Next is the contouring system. In continuous system is also known as continuous path system. The positioning and cutting operations are both along controlled paths. This positioning of tool and cutting operation is controlled by the path movements, but at different velocities. Because the tool cuts travels along the path, accurate control and synchronization velocities and movements are important. The contouring system is used as lathe, milling machines, grinders, welding machinery and machining centers. So the image shows the continuous path numerical control motion systems. So that it's continuously moving from the one point to another point. There are different types of control systems used in the computer numerical control systems, such as open loop system and closed loop systems. The open loop system, which consists control unit, driver and motor. The simple control systems. The closed loop systems, which includes feedback control systems, which is used to provide the feedback signals to the systems. Open loop systems. In open loop system, the signals are given to the motor by processor, but the movements and final destinations of work table not accurate. This figure shows the image of the open loop systems. The input, it's transfer the controller and control the process then its output. There is no feedback system which is not included in the open loop systems. Then open loop system cannot be accurate, but it still can produce a shape that is required. Show that output is the system is not accurate, but however that required shape can be produced. The required image has been produced. For open loop system is normally the stepper motor is utilized. In closed loop systems, is equipped with various components such as transducers, sensors and counters, which is used to measure the position of the table accurately through the feedback control systems. The position of the work table is compared against the signal. The movement of the work table is based on the signal. The table movements terminate when the proper coordinates are reached. For the closed loop system is normally operated by servo motor. The closed loop system is more complicated and more expensive than open loop systems. So the closed loop system, the figure shows the various components of the closed loop systems. Its input, an amplifier, controller, processor, then it's having the controlled output. The error signal has been rectified the errors, and then it's have the feedback system which is provide the feedback signal to the input. So the other cycle has been repeated. So another important things are coordination systems. We have two different types of coordinations. Is the Cartesian coordinate systems. Another one is the incremental coordination systems. So the Cartesian coordinate systems concern that the Cartesian coordinate system is an accurate and coordinate system that specify the each point uniquely in a plane by a set of numerical coordinates. The set of numerical coordinates which is used to specify the each and every point in the coordinate systems, which are signed distances to the point from two fixed perpendicular oriented lines measured in the same unit of length. It's measured the basis on the Fleming's left hand rule. So this figure shows the Cartesian coordinate systems. Another one is the incremental coordinate systems. Incremental coordinate system is called incremental coordinate programming G91 of machining the machine center. In incremental systems of every measurement refers to a previously diamond positions. So the incremental system is refer the previously diamond position system such as point to point. The incremental dimensions are distance between the two adjacent points. So mainly its incremental dimensions based on between the two adjacent points. And how computer numerical control working on the principles. Each axis consists of mechanical component such as slide that moves a servo drive motor that powers the mechanical movement. So the servo motor provides the power to this mechanical movement, this mechanical operations. The ball screw it transforms the power from servo drive motor to the mechanical component. The ball screw which is used to transfer the power from servo motor to the mechanical component. These components along with the computer controls that govern them are referred to the axis of the drive systems. The working of CNC. Using a vertical mill machining center as shown in the example, there are typically three linear axes of the motions. Each axis is given by alphabetic designation or address. The machine table motion, its move from side to side is called as the x-axis, and the table movement of is in and out is called the y-axis. The downside movement column of the is called z-axis. The servo motor mechanisms, drive mechanisms, which used to help to provide the power transmission through the machine elements. So the tolerant tool cutting forces, servo drive is tolerant to the tool cutting forces. It is insensitive to load mass inertias, insensitive to running friction forces, and linear to high degree. These are the function of servo drive mechanisms and work positioning of the work table. The method of accurate work positioning in relation to the cutting tool is called the rectangular coordinate systems. The method of accurate work positioning which is related to the cutting tool is called the rectangular coordinate systems. And the vertical mill, the horizontal baseline is designated in the x-axis, while the vertical baseline designated in the y-axis. In the z-axis at the right angle perpendicular to both and x and y-axis. So in vertical mill, in the horizontal baseline it's indicated as the x-axis. The vertical baseline is indicated as the y-axis, but the z-axis is the right angle perpendicular to both x and y-axis. Work positioning. The increments of all baselines are specified in linear measurement for most of the machines. The rectangular coordinate systems allow the mathematical plotting of points in space. These points are locations called coordinates. The coordinates in turn relate to the tool center and dictate the tool path through the work. The coordinates which helps to the movement of the tool center and dictate the tool path through the complete the work process. CNC part programming. The part program is simply a series of command blocks that executes the motion and machine functions in order to manufacture a part of the components or machines elements. Basically, the part program is simply a series of command blocks. Is the command blocks that which is used to execute the motions and machine functions as per the manufactured part in order to the manufactured part. The various methods of creating the part programs such as manual part programming, computer assisted part programming, which include the APT programming, CAD/CAM based programming, interactive or conversational programming, and verbal programming. Then another the CNC dimensioning. There are two types of dimensioning: the incremental dimensioning, and another one is the absolute dimensioning. The incremental dimensioning, the tool movement is measured from the last tool positions. In incremental dimension method, it is measured from the last tool positions. The program movement is based on the change in position between two successive points. The program movement is based on the position of two successive points, which figure shows the incremental dimensioning. But absolute dimensioning concerns that in absolute programming, that all measurements are made from the part of origin established by the programmer and set of the operator. It's start from the all measurements is made from the part of the origin. The origin is designated by the either programmer or operators. So another important in the computer part programming, which include the two main codes, G codes and another one is the M codes. The G code stands which is for the specify the preparatory functions. The preparatory function is designated in a program by words address G followed by two digits. The preparatory functions also called as G codes, and they specify the control mode of operations. The G codes which is used to control the mode of operations. G codes fall into two categories. One in non-modal or single shot codes that are only active in the block. Mainly the G code having the two categories. One is a non-modal or single shot codes, which is used to only in the active in the block. Other one is the modal codes that will remain active until the another code of the same group overrides. So until the another code in the same group which overrides, so it should be remain active. Some of the used G codes are for the part programming, such as 000. It's for mentioning the rapid traverse. This is the motion of the tool, the rapid traverse. G01, which refers to the linear traverse, and G03, it's counterclockwise and circular interpolation. So that each and every codes having the different set of functions. Another important code is the M code, which denotes the miscellaneous functions. The miscellaneous functions use the address letter M followed by two digits. They perform a group of instructions such as coolant on off, spindle on off, tool change, program stop, or program end. This kind of operation denoted by using M code. These kind of miscellaneous functions denoted by M codes. Some of M codes are M00, the program stop, M02, end of program, M03, start spindle. These are some examples of M codes. Some various advantages of computer numerical control. Computer numerical control is highly repeatability and precision. Example, aircraft parts. The volume of production is very high. Complex of contour surfaces need to be machined. Example, turbines, show that its high volume of production has been done in the CNC, and the complex contour surfaces have been done through the CNC. Example, turbine shapes. Flexibility in job change, automatically tool settings, less scrapping, so that we can the flexibility in the change of jobs frequently and automatically tool change settings, change of tools, and so that the scrap has been reduced. It should be more safe for the operators and programmers. It's produce high productivity. It provides better quality. So less paperwork, faster prototype productions, reduction in lead times. The manufacturing time also it's reduced. Some limitations in that CNC machines, such as costly setup, needs skilled operators. Operators must know the CNC part programming. The computer's programming knowledge is required for the operators. Highly initial cost, highly maintenance cost, highly tooling cost, the requirement of highly skilled manpower, need of conditional environment. So its conditional environment is required for the CNC machines operations. There are various softwares which is used for manufacturing software in computer aided manufacturing, such as Fusion 360, Solid Edge, HSM, SolidWorks, CAM, CAMWorks, NXCAM, GibbsCAM, PowerMill, MeshCAM, OneCNC, MasterCAM. These are the softwares which are used for the computer aided manufacturing and CNC programmings.
So far we have discussed the topic on CNC machines. what is CNC machines, the principle and function of CNC machines, various application of CNC machines. Also, we have discussed the types of control system such as open loop and closed loop control systems. Also, we have discussed motion control system such as point-to-point control system and contour control systems. Also, we have discussed work positioning and working principle of CNC machines. Also, we have discussed various coordinate systems and various applications and advantages and limitation of computer numerical control machines such as CNC machines. Also, we have discussed computer part programming such as G codes and M codes. Learners, hope you might have understood the basics and fundamental and principle of CNC machines. Thanks for the listening.